After grading the Unit 1 test, there were some noticeable deficiencies in some of our understanding on some of the standards. And in about a week, we have our first project proficiency test where it is standard-based grading, and you have to show that you do have understanding and comprehension of the standards that are on that test. If you miss a standard on that test, I will put you with a failing grade until you do recovery for that standard. So hopefully we're going to recover some of that information here today before we take the test in about a week. And so this recovery is going to focus on isotopes. And so what I'd like you to do as you watch this video here with your classmates is go through and complete the note guide that goes with it. You will have a set of problems after you complete the note guide to complete before you can retake that portion of the test. And you are required to have the note guide filled out before you can do the problems. So this is the first step. The first part here that we're going to talk about is the similarities and differences between isotopes, or atoms of the same element that are considered isotopes. And so what exactly are isotopes? Isotopes are atoms of the same element, and this is determined by the atomic number. It is the protons that determine what the atom is. So if it has 11 protons, it's going to be sodium. If it has 12 protons, it's going to be magnesium. If it has 9 protons, it's going to be fluorine. That determines what element it is. So when we talk about isotopes of an element, it is going to be two atoms that have the same exact number of protons and electrons, same atomic number. What's going to be different is the atomic mass, and this is where isotopes for an atom or for an element are different. This is two atoms of the same element that have different atomic masses, so they have a different number of neutrons. This difference in neutrons here doesn't change the chemical or physical properties of that element. Sometimes it does give it a little bit of a radioactive decay to it, but the way the element looks and reacts is going to be the same. That basically sums up what an isotope is. The next part of this here that we're going to look at is how do you determine if something is an isotope or not. So for our first example of sodium here, what I'm asking you to do is copy down the number of protons, neutrons, and electrons, and we're going to identify what makes these isotopes. So if we look at the atom of sodium on the left-hand side, we see that its atomic number is 11, and that atomic number tells us number of protons, so there's 11 protons and there's 11 electrons. Now to figure out the neutrons, I'm going to take the atomic mass, 23, and I'm going to subtract my number of protons, which is 11, and that's going to give me 12. If we look at the atom of sodium on the right-hand side, I have 11 protons again and 11 electrons. But now when I subtract the 11 protons from my atomic mass, I find out that I have 13 neutrons. It is the difference here in the neutrons that makes this an isotope. The protons and electrons are exactly the same, so it's the same element, it's just two different atoms of it. They are isotopes of each other because they have different number of neutrons and a different atomic mass. The next two examples are going to cover examples that are not isotopes for different reasons. So if we look at magnesium 24, and both these atoms are considered magnesium 24, so sometimes you refer to it based on its weight. We see that we have 12 protons, 12 electrons for both of them. But now in this example what we have here is we have an atomic mass of 24 on the left, which gives us 12 protons, and an atomic mass of 24 on the right, minus 12 protons, which gives us 12 neutrons also. So when we look at this now, I still have the same number of protons and electrons, meaning that these atoms are both atoms of magnesium, because that same atomic number, but they have the same number of neutrons. So these are not isotopes of each other. These are just two atoms of magnesium. Let's look at our third example. On the left I have nitrogen 14, and on the right I have oxygen 16. So here I have 7 protons, 7 electrons, 7 neutrons, and on the right I have 8 protons, 8 electrons, and 8 neutrons. And if we look at this one here, not only do we not have, well, here we have a different number of neutrons, okay, so that could potentially identify it as being an isotope. But what's going to eliminate the possibility of this being an isotope of each other is if we look at the protons and electrons, for both of these, they aren't the same. So these aren't even atoms of the same element. So atoms of different elements cannot be isotopes of each other. Here the atomic mass doesn't matter at all because they're not the same. So after you've completed your note guide, what I'd like you to do is go ahead and show it to me, and I'll come around with a set of questions for you that you'll have to answer to go with it. The questions are going to be CR format, so claim, evidence, reasoning, and I want you to give me specific evidence telling me why they are isotopes of each other or why they are not. You need to do this in order to successfully recover the standard and retake the Unit 1 test if you missed it there. So go ahead, show this to me, and we'll get you right on the back on the right track.